Welcome to section 12.3, Simplifying Rational Expressions, and this is video 1. In this video, we'll talk about simplifying basic rational expressions. We'll identify excluded values, and I believe that is all that we'll be talking about. So we're just doing some basics of simplification. The next video, we'll talk about that opposite sort of thing, and that sort of thing that we barely touched on in the end of class. So, first of all, a rational expression is an algebraic expression whose numerator and denominator are polynomials. So the top and the bottom are polynomials. They're like 5x plus 7, or 7x squared minus 15 plus 2, or 15x plus 2. As well, we are going to be simplifying rational expressions, so we'll be doing that through these 3 steps. Step number 1, we'll identify any of our excluded values. Step number 2, we're going to factor the top and the bottom, if possible, of the expression and find like terms. And then lastly, we'll simplify each rational expression by dividing by the like terms. So, let's go through and practice some. Here we go. Here's our first problem, and as you can see, we have our steps there with us. So our step number 1, we need to identify any excluded values, and in that case, we're only looking at the denominator, so we have 12t to the third, and if that was equal to 0, essentially t would equal 0. So we're going to just hold this concept in our back pocket, and it'll be part of our final answer. After that, we need to factor the top and the bottom, if possible, of the expression to find like terms. So let's think. What are like terms within 3t to the third and 12t to the third? Well, we have 3t to the third in the top part, and we have 12t to the third. So we could probably take out a 3t to the third and multiply that by 4, and we get 12t to the third. So in all reality, that is our next step. We've kind of simplified this. Our last step is simply taking 3t to the third over 3t to the third times 4 and simplifying this a little bit and saying, okay, this 3t to the third at the top and the 3t to the third on the bottom, those cancel out. So they become, on the top, we just simply have 1 left over, and on the bottom, we still have 4. So 1/4 is our final answer, but we're also going to add on to this little thing, t cannot equal 0. So our final answer is 1/4, but t can't equal 0. So let's try another problem, see how we do with this. Let's go through this whole concept again. We have 3x squared minus 9x is over x minus 3. So first things first, we need to identify our excluded values, so we're paying attention to that denominator. We have x minus 3, and we're going to set that to equal to 0, because when we do that, we can solve for x, and if x was equal to 3 in this case, everything in the bottom would be equal to 0, so therefore that would make our equation undefined. And we don't want that. We want to be able to find all the other possibilities. So we have now our step number 2. We have 3x squared minus 9x over x minus 3. So we need to factor. The bottom is completely factored, so we're going to rewrite that as x minus 3. Our top portion, though, we need to simplify. If I look at this top portion, I have an x in both terms, so I can factor out an x, and I also have a 3 in both terms if I factored it out. So I can say 3x is going to be factored out. If that's the case, 3x squared, what would be left over is just an x, and of minus 9x, I'd have a minus 3 left over. So we have factored it out, and what's kind of nice is when we look at this, I see a common set of terms. So essentially that x minus 3 can then be simplified. So we have this 3x times x minus 3 over x minus 3 on the top and the bottom. So to do our final simplification, we are going to simply divide the top and the bottom equation or expression by x minus 3. So all we are left over is 3x, where x cannot equal 3 as our final answer. So we're going through every single one of these steps. Let's try one more problem and see how this goes. Actually, I think we have a couple more problems. So simplify the rational expressions. We have identify the excluded values for k plus 1 divided by k squared minus 4k minus 5. So first things first, we need to pay attention to this denominator. We have k squared minus 4k minus 5. And when we're looking at this, we can't actually find out what this is, what k's make it equal to 1 or make it equal to 0 unless we do bottoms up or we do some factoring. So this factoring can easily be done with some guess and check. So we could say k minus 5, essentially what numbers are factors of 5 that could add to or subtract to be a negative 4. So we have 5 and 1. 5 and 1 can essentially go there, so we'd have 5 and 1. And we have a negative 4 there, so that means that that 5 is going to be bigger, so we can say k minus 5 equals, k minus 5 times k plus 1 is equal to 0. And our final step would be to say k minus 5, if that were equal to 0, what would k be? Well, k would be a positive 5. And for the other side, k plus 1, we'd have a negative 1. So for our equation, we would essentially have two vertical asymptotes where k is equal to 5 and k is equal to negative 1. So both of those are not potential answers to our problem. Okay, so now after that we need to actually look and factor out the top and the bottom. So our top is still k plus 1 because k plus 1 is totally factored. But the bottom, we've already done the math work to factor it. We found k minus 5, that quantity multiplied k times k plus 1 is equal to our original equation. So now we've factored it, which is awesome. We did factoring in the first step right away. We got it taken care of. That's always nice. And now our last little bit is we need to simplify. So we have k plus 1 on the top over k minus 5 times k plus 1. So our common term that we could potentially factor out is k plus 1 over k plus 1. K plus 1 over k plus 1 is essentially just a special way of writing the number 1. So we have essentially 1 over 1 there, so we could say, oh, that is all equal to 1 over k minus 5, everything that is left over. And that's not our final answer, so I'm going to actually erase that. We also have a situation where k cannot equal a positive 5 or a negative 1. And that is our final answer. So now let's go on and try one last problem. I believe that's it. Yep, one last problem. So here is our problem. Y squared minus 16 divided by y squared minus 8y plus 16. So first of all, as always, we need to identify our excluded values. So we're looking at y squared minus 8y plus 16. And if you don't notice right at first that this is a perfect square trinomial, you could completely do bottoms up. But I noticed that it's a perfect square trinomial, so I'm going to separate this out. We have y squared, that becomes y times y. 16 becomes 4 times 4. So we have y minus 4 times y minus 4. That is what the bottom part factors out to be. So essentially y could equal 4. And if y would equal 4, then both of these two equations or expressions would become 0. And therefore this whole entire expression would be undefined if there was an equal sign. So we know that essentially in our back pocket we're going to say y will not be able to equal 4. Now we need to factor the top and the bottom if possible. We've already done the bottom, which is really nice. So we have y minus 4 times y minus 4. And on the top we need to do y squared minus 16. And once again, that is one of our special binomial products. So this right here will turn into y plus 4 times y minus 4. It is our difference of squares, if you remember right. So, last little bit, we need to have our final sort of answer. We have our final factoring taken care of. So we have y plus 4 over y minus times y minus 4 over y minus 4 times y minus 4. So our last little bit is to simplify. I have y minus 4 at least once in both the top and the bottom. So that means if I have it once in the top, I can take away one of them in the bottom. And so my final answer for this problem will be y plus 4 over y minus 4, where y cannot equal a positive 4. And that will be my final answer. Play around with some of these problems on the homework, and also be sure to watch the second video of 12.3, and I hope this video can help solve some of your dilemmas with your homework. Ciao.